rational and irrational numbers, lesson 1 notes. Now we're going to talk about irrational numbers. Irrational numbers cannot be written as a ratio of two integers. In other words, irrational numbers are decimal numbers that go on forever. They go on forever and they do not repeat. So irrational numbers are decimal numbers that do not repeat nor terminate. Remember, terminate means to end. So they don't repeat and they don't terminate. Okay, let me go back to my joke. What do you know about the number pi? Well, pi is a number that goes on forever. A lot of you know it as 3.14. Some might even know some more numbers, 3.141592, and so forth. It goes on forever. So, but it has no repeating pattern. There's no numbers that repeat over and over again. Therefore, pi is an irrational number, and that is why the square root of -1 is telling pi to be rational. I know, haha. Well, if you would also try to put the square root of -1 into your calculator, it would say that there was a domain error, sorry. And that's because you can't take the square root of a negative number, because no number squared would give you a negative answer, because you're multiplying two numbers together and two negatives would become positive, two positives would remain positive, and therefore you cannot take the square root of -1. So the square root of -1 is not a real number. It's not a real number. Hence pi is telling that to get real. So yes, I know the joke isn't that funny, but now you understand it. Pi is an irrational number, and that's why it's being told to be rational. So let's go back to the notes. So pi is probably the most famous irrational number. So pi equals 3.141592653589793238, and it keeps going on forever. Yes, there are numbers that repeat. You see 5 multiple times, 9 multiple times, and so forth. But there's no pattern of the same number or numbers repeating over and over again. Therefore, it's not a repeating decimal, and it does not end, so it does not terminate. Another irrational number. 0.123, 1233, 12333, and so forth. A lot of times I'll have people argue with, well, there's a pattern here. Well, yes, there is a pattern. But in order to be a repeating decimal, the same thing must repeat over and over and over again. So it'd have to be 123, 123, 123, 123, and so forth. But each time it's adding another 3. It went 123, then 1233, and so forth. That would make that an irrational number because it was going to go on forever, and it does not repeat. Now, let's go back to this. When I put the square root of 5 in my calculator, the first thing it gives me right back is actually the square root of 5. If you're using the school calculator, it will give you the square root of 5 back. And then you hit what I like to call the arrows button. So if I come down here, it's this button right here. I like to call that the arrows button. So if you put the square root of 5 in your calculator, it gives you back the square root of 5. You hit the arrows button, it gives you 2.2360, and there's some other numbers, but I only wrote 4 decimal numbers down, and then I put the ellipse. So the square root of 5 is 2.2360, and then the ellipse keeps going. If I put the square root of 12 into the calculator, it gives me back 2 root 3. That's how you would say this right here, 2 root 3. So it gave me back the root symbol again. If I press the arrows button, I get 3.4641 and so forth. It keeps going. Neither one of these are terminating decimals. It doesn't terminate and it doesn't repeat. So these are decimals that do not terminate nor repeat. Therefore, they are irrational numbers. If you're using the school calculators and the calculator gives you back the root sign, automatically you know it's an irrational number. Again, if you're using the school calculator and the calculator gives you back the root symbol, it is going to automatically be an irrational number. So let me show you some more examples. Okay. The square root of 200 gives you back 10 root 2. As soon as it gave me that root symbol, I know it's an irrational number. So 10 root 2 is 14.1421, and it keeps going on forever. The square root of 60 gives me 2 root 15. So again, it gives me the root sign. I know it's an irrational number. 7.7459 and so forth would be the square root of 60. The square root of 250 gives me 5 root 10. Again, it gives me the root symbol back. It is an irrational number. 15.8113 and so forth would be the square root of 250. The square root of 1,000. Now, I put this one as an example because the square root of 1,000 just gives me the decimal number. And sometimes it does it. The larger it gets, it just gives you a decimal number. Therefore, you should recognize still, though, you should still recognize that. See how these numbers keep going and going? Okay? That's going to go on forever. And again, the square root of 1,000 would be an irrational number. That decimal does not end, nor does it repeat. Okay, so again, if the calculator gives you back the root symbol, it's automatically going to be an irrational number. Going back to our notes. So let's write down the example, another example. Pi squared. Well, pi is irrational, so if you square it, it's still going to be irrational. 9.86960440109, and the ellipse because it keeps going on forever. Also, the square root of 5, 2.23606797, and it keeps going. So that's an irrational number. Pause your video and get those numbers written down. Now, I wanted you to notice that sometimes when we took the square root, we got a rational answer. But sometimes when we took the square root, we got an irrational number. So if we look at this again, sometimes when we took the square root, we got a rational number. Sometimes when we took the square root, we got an irrational number. It all depends on what the number is that you're taking the square root of. 4 is called a perfect square. 1.44 is also a perfect square because 2 squared is 4. 1.2 squared is 1.44. So when you take the square root of a perfect square, you get a rational answer. But all other square roots will give you an irrational answer. So our fill in the blanks here are: the square root of a perfect square is rational. All other square roots are irrational. So one more time. Rational numbers are fractions of integers, repeating decimals, terminating decimals, or just integers themselves. Irrational numbers are decimals that do not repeat nor terminate. They do not repeat nor terminate. So it's a number that goes on forever but does not repeat. And again, if you put the square root of a number into your calculator and the calculator gives you the root sign back, it's automatically going to be irrational. If you have any questions on irrational numbers, let me know.